This is our lab report for the Wien-Bridge oscillator, presented to you by Muhammad Shafiq bin Ahmad Aziz, Muhammad Firdaus Amin bin Anwar, and Muhammad Arif Amin bin Zulkifli. So, uh, for Wien-Bridge oscillator, the Wien-Bridge oscillator is known as electronic oscillator that produces sine waves. It uses operational amplifier and an RC circuit amplifier circuit, and it has a high quality of resonant frequency, low distortion, and also in tuning. So so below is the formula, a mathematical formula that we use to obtain the oscillation frequency and the amplifier resistor ratio. So moving on to the figure one. Okay, for the procedure for figure one, first we need to calculate the oscillation frequency of one bridge oscillator, and this will be shown later. And next, we will design the circuit by using multisim. You can show the figure one, please.
Oh,
The multisim. All right. Okay, so this is the circuit that we constructed, and as we know that to activate this oscillator, we need to the the frequency of RF must be equal to 2RA. So we need to adjust the value of a rival resistor. And this is the output that we obtain. Uh, the frequency oscillator must be close to the manual, the theoretical value of the frequency oscillator that we obtain. And this is the manual calculation that we got. So moving on to figure two.
For figure 2, uh, the circuit is almost the same with the figure 1, but uh, we change a bit on the RF. We put the diode, and also we change the number of resistor in the RF. And also we still using a potentiometer with 10k potentiometer. But the output is still the same as a figure 1, equal to 1.28 kilohertz. For the question, this is the question, and the answer is over there in the report. And for discussion, based on this simulation, we use multisim software to design the figure 1 circuit, which is Wien-Bridge oscillator circuit. By using operational amplifier in a non-inverting configuration and feedback form of a voltage divider network, which means that the output gain of the amplifier become positive in the value as amplify act as active device. For Wien-Bridge oscillator produce continuous output oscillation, we need to obtain a stable oscillation. The gain of the op amp V out over V in must be plus 3, positive 3. This is determined by RF and RA according to the relationship by the procedure.
and for the second part of the discussion is about this lab is about two circuit experiment was conduct, where we can see in the one bridge oscillator circuit the variable resistor is adjusted to be 2 times more than RA. So there will be exist distortion on the waveform once the amplifier resistor ratio is 41% and above, 41% and above. And if the amplifier resistor is below 40%, there will be a dropping in waveform and suddenly will be no waveform. So for the figure 2, the amplitude stabilization was added in the circuit, and the amount of amplifier resistor ratio needed is only 70% to get smooth output waveform. So we only using 70% to gain our output waveform pretty smooth. And the amplitude stabilization is obtained by using the diodes. When a diode is conducting, the amplitude of the output voltage is limited to prevent high output gain that allow distortion in the waveform. So for the conclusion for this lab is we are able to simulate and also to observe the effect of varying different components on the output of the wine bridge oscillator. And then we are also able to design the wine bridge oscillator and an audio frequency sine wave oscillator with the chosen frequency by usage of the multisim software. That's all from us for this lab 4, which is Wine-Bridge Oscillator. Thank you, sir.